Today we are covering scaled product attention. The core formula behind attention weights. The goal is not to memorize a slogan. The goal is to build an interview-ready explanation that moves from intuition, to mechanics, to trade-offs, and then to a concrete example. Intuition. Scaled product attention is a learned lookup. A query searches, keys are compared against it, softmax chooses weights, and values are blended into a context-aware output. If you remember only one thing, remember the shape of the problem. Raw information is transformed into a representation that makes the next decision easier. Core mechanics. Queries, keys, and values are linear projections of token states. Products measure query key compatibility. Scaling by square root of key dimension keeps scores numerically stable. Softmax converts scores into a probability-like distribution. The weighted sum of values becomes the new representation. The compact mental model is attention QKV equals softmax QK slash square root DV. Do not rush past the symbols. In an interview, define each part in plain language before you talk about implementation. That makes you sound like you understand the system, not like you only memorized notation. Common traps. Skipping the scale can make softmax too sharp when dimensions grow. Attention weights are not always a perfect explanation of reasoning. Every token attending to every token creates quadratic. Cost masks may be required to block future or padding tokens. Concrete example. For the token it in a sentence, the query may strongly match the key for a previous noun. The resulting value mix helps the model represent what it refers to. Walk through the example slowly. Say what changes at each step, what stays fixed, and why the operation helps the model produce a better representation. Interview checklist. Define Q, K, and V. Write the formula correctly. Explain scaling and softmax. Mention masks when relevant. Name the O in superscript 2, cost. A strong final answer for scaled product attention should have 4 beats. First, give the intuition. Second, name the components. Third, describe the formula or data flow. Fourth, mention the trade-off. If you can add one example, you will usually sound much more practical than someone who only gives a textbook definition. Now let us rehearse the answer in a more conversational way. Start broad. What problem are we solving, and why did this idea become useful in modern AI systems? Then narrow down, what data structure or tensor is being manipulated? Then explain the operation. What is multiplied, normalized, added, masked, or learned? Finally, connect it to behavior, faster training, better context, more stable gradients, lower memory cost, or clearer generalization. For interview practice, avoid 3 mistakes. Do not give only math without intuition. Do not give only intuition without naming the mechanism. And do not pretend there is no trade-off. Most AI interview questions are really trade-off questions wearing a concept label. The best answer shows you know when the method works, when it becomes expensive, and how engineers usually manage that cost. Quick recap: scaled product attention. The core formula behind attention weights. Use the mental model, define the pieces, give the example, and close with the practical trade-off. That is the answer structure to keep in your head. One more interview rehearsal. Explain it as if teaching a teammate. Define the input, describe the transformation, name the output, and close with why the design choice matters in real systems. This habit turns a memorized answer into a practical engineering answer. Second rehearsal. If the interviewer asks for more depth, connect the idea to tensors and runtime behavior. What is stored in memory? Which dimension grows with sequence length, hidden size, or number of heads? Which part is learned, and which part is a fixed rule? These details separate a surface-level answer from an engineering answer.